Ooh, that took me a second. Almost didn't make it. Um, sorry. Yeah. So I think I have everything I need now. This morning I went and I assembled the keyboard, put it all together. So we're gonna take a look at that keyboard. Um, let's see what else is interesting. Yeah, keyboard assembled. We should be able to program it now. We're also gonna place all the keys. Um, Anything else? I had some pretty interesting ideas, stuff to explore during this stream to make things easier. But let's go ahead. Let's jump in. So same box, but these are not coming straight from JLC. This now is assembled. So I did two. So we've got the Pico 2 on there now. And yeah. So we've got two of these. I did take videos while I was in the lab. So I think I'm going to try to put together a full video later of kind of collect everything for this keyboard. If it works, if it doesn't work, I'm going to throw out everything. Useless photos. But yeah, we can basically just put the key switches in and power this up and start to play with it. There's not much more to do. So let's play some switches. Let's see, camera number 2 is unplugged. We'll get a little assembly camera going. Okay, let's see if that works. My system doesn't love me connecting a million cameras, so... Oh, yeah, nice. Okay. It's a little bit of a better vantage point, I think, for this one. Might be able to make it even better. Yeah, okay. I have, like, a complete mess of wires because, you know... still trying to figure out what to do with this desk. But let's get into it. We got a bunch of switches to place. We're going to literally place like 18 right now. Spill those out. So I've noticed I do kind of have to bend the pin. I don't know if that's me being dumb when I put this in, but yeah, I kind of got to bend the pin just a little bit. Should be impossible to put these in backwards. So you don't need these hot sockets, these key switch hot sockets. The only reason to have them is if you're trying to save money. Because, you know, if this board is messed up, you get to kind of like pop out all your switches. Because I guess these are like, I don't know, 50 cents a piece, these little switches. So on a board like this, it's not going to save you that much, but on a bigger board, it actually saves you quite a bit of money. The sockets aren't that cheap, so, you know, but no, we'll see. We'll see if I continue using them. I don't like doing any assembly, so I've been devising a plan all morning to get rid of the stamp assembly. I have an idea for this thing. I'm gonna call a stamp. I think the solder is good. Yeah, I think it's okay. Actually, we'll look at it. I have a video of it under the microscope, and I think it's okay. It's been a while since I you know, did like, I used hot air. I basically did a hot air outside of an oven. I didn't use a hot plate like I thought I would, so it's been a while since I've done that. Yeah, what was yeah. Anyway, so we're gonna assemble 2 boards. I'm almost done with this one, and then we'll be able to try to program it. And I hope I brought 2 cables over. I don't know if micro USB has a power only cable. I know USB-C does, but There's a chance that one of these is power only, so I brought a couple. I know one of them is data compatible. I have never programmed a Pico 2, so there's probably going to be a lot of dumbassery as I try to figure out how to program this. I think you can use the Arduino IDE, which I also do not have installed. So yeah, there's going to be some dumbassery. All you need is a 3D printed case. I mean, maybe, yeah. I'm so happy. I mean, to me, of course I cared the most about the PCB, but to me, probably the most important thing, or the thing I would want to do after this, is to get the Pico 2, get rid of the Pico 2, and go straight to RP2350, because that will be, then I don't have to do any soldering. I might be able to get it fully assembled elsewhere. The hardest part of that is the RP2350 is really new. In fact, it's so new, I probably can't get it fully assembled. It's almost possible. There's one chip that would be hard. The RP2350, the main black chip on the Pico. Yeah. Yeah. But programming this should be pretty fun. It's a super overpowered microcontroller for this task. By the way, kind of boring, but what I like about the 2350 is it has a USB controller on board. So that is why I'm very excited to use it. RP2040, I do not believe it does. I think you can program it, maybe, so that it does, but because it has this thing called a PIO. But yeah. Anyway, all right, we're fully assembled. Browns. Somebody asked earlier, Browns. I don't know if I'm going to mess around with keycaps. I don't know if I care. Should I put on keycaps? I'll put keycaps on one. It's really aesthetic. I also realized I got like multicolored keycaps. I guess like it's kind of dumb. The worst thing would be if I put it on the RP20 or the Pico 2 backwards, but I'm almost positive I did not do that. Oh, those really snap in there. Okay. I'm trying to think which way. I haven't looked at these keys in a while. I can't tell if this is backwards or not. I don't know. I will only know once every key is on. Because it's definitely not symmetric. I don't know. Does that look right? It's kind of like, I don't know. This reminds me of building with Lego. When I used to build with Lego, I never cared about like matching colors. And it made everything look really stupid. No boring, all good. Let's see. Get some keycaps on. Yeah, this is really going to be like this is really going to be an experience trying to program this. I have not done anything. Like I haven't even installed Arduino on my PC. So, yeah, this will be a good time. I think I can probably install it with a cask, so I'm guessing that'll only take a second. But yeah, we'll see. We're definitely going to use AI to write some of the control software. I don't know. You know what's weird is I think these sockets actually make, I don't know, it just doesn't look that symmetric to me. I could be crazy. It doesn't look super symmetric to me. But okay. So the most important test to run, I do use Homebrew. Most important test to run is the smoke test. So I plug in the Pico, and if I don't see any smoke, I also touch the micro a little bit. If it doesn't get hot, that means it's probably not going to explode. I failed this test many times. So let's give this a go. I already soldered. I did it. I already did it, AI Doom. I soldered the Pico 2 on. So there should be no more soldering to get this to work. But as Imposter was saying, I could put it into a case. Also, I should probably put the chat up on this OBS window. I'll do that later. All right, so this should turn on. We should see an LED light up. Oop. Ooh, that is... Oh, no! Okay. Wasn't expecting that. So, usually USB connectors go off the board, and because this one doesn't go off the board, the plastic shielding around this actually prevents me from plugging it in. But this one has a more narrow plastic shielding. I think this one will work. So hopefully this cable I was worried about. I think I bought this as a charging cable. So hopefully we have data support. Also, let's clean up a little bit. I wonder how much these key caps cost, or these key switches. He deprived us from the spectacle. I recorded it. I actually spent a lot of time putting the camera up in the lab, but because it was totally empty, so I totally could have live streamed from there. But the thing is like, you know, I had to like prop stuff up for a while to get a good shot. So like, I think it was a good compromise, because if I was doing it live, it would have taken forever. Yeah. He deprived us from the spectacle. That's such a funny way to say that. If not, get the knife and shave it off. That is insane, but it would work. Oh my god, this is going to be so close. I might tear it off with the pressure. Oh no. Okay, let me think. I did not anticipate this very stupid thing. Let me try to show this up close. So, trying to think about angles here. So when let's do this, maybe. Does that work? Yeah, so it's I think you can see it like this, kind of. It's like lifting it off, and I didn't do the best job soldering, so I'm really worried when I plug it in, it's going to tear it off. But, you know, YOLO, we have 2 boards. Okay, plugged in. Looks okay. All right, so that's definitely a thing to revise in the future version, but it looks okay. I don't see a light. Is it supposed to light up? I've never plugged in a Pico 2, so I have no idea. What does a Pico 2 do? Maybe it doesn't light up. I do see an LED on it, but it might not. I mean, that would make sense if it didn't light up just when you plugged it in. I have too many expectations. Let's get Arduino installed. Let's figure out what's going on. Wow, that's concerning. That it's kind of like lifting it off the board. I'm like, yeah, I don't love that. Somebody mentioned, oh my gosh, where's my window? Install Arduino Mac. I'm going to try to multitask a little bit. Why does it say Arduino IDE 1? What is that? 2. Okay. Apple Silicon. Just download. Just download. It's very popular with oh, I guess I could have used Homebrew. I forgot I was going to use Homebrew. Whatever. That was easy enough. Is it installed now? Arduino. Arduino. Sure. Select board. Board is not appearing. WLAN debug. Bluetooth incoming port. Why do I feel like no boards found for Pico 2? All right, we might have to do some Googling. I mean, if you drop it, the keys will go flying. Probably true. So let's see, Pico 2 Arduino IDE. Maybe it doesn't work. I don't really care if it doesn't work. I'll figure it out. Raspberry Pi Pico 2 launched August 8th. You might need to unplug and plug back. Awesome. I might have to change my display settings here, because I think the scaling in this IDE isn't going to be too great for live streaming. Oh, nice. I think OBS automatically adjusted. So yeah, we've got big text now. Good. We will do imposter suggestion of unplugging and plugging back in. Oh, that is painful. It feels like I'm ripping it off the board. Oh, that is not good. Oh. So what I would do, yeah, and you know what? I can't take pliers to it either, to the fiberglass, because okay, well, I won't unplug it on this side. That is really stuck in there. Wow, what a sad way to go on that one. uh okay. Unplugging and replugging didn't work, at least from my uh whatever USB hub. I wonder if I don't know, maybe I could probably clip this a little bit to make it better. I just need like clippers. I don't know. Have you used Platform IO? I have. Yeah, I would use Platform IO. Honestly, I'm cool with a lot of different tools, you know what I mean? Like I'm down for anything to get this work. I will boot freaking Windows, you know. I'm so used to shitty old software when I'm doing microcontroller stuff cuz I've used like Silicon Labs and all that nonsense. All right. To give you a sense of what I'm looking at, I'm kind of like staring at this and I'm like, all right. What are the chances? Hmm. I need to look up a Pico 2 tutorial. I don't want to get too much in my own head. Uh okay, Pico 2 tutorial. Who's listening to that? Not me. Pico 2 tutorial. Arduino ID. Maybe Pico 2 isn't compatible because it didn't show up in the little selector. Let's just look up without Arduino. Pico 2. Oh, wow. Is this thing that new? What do I need to know before I buy?
Raspberry Pi Pico 2, then this video is for you. Here are 10 things you must know about this new board before buying. 1. Meet the new RP2350.
All right, give me one sec. Don't you have a spare Pi 2? Plug that in. Yeah, I have tons of spares. Um, sorry, a little bit of a cable mess. Let's see. Could have swore I just had a micro USB. There it is. Yeah, there we go. Okay, so we're gonna use this cable, which I know works as a data cable. And then where would my extra Pico 2 is in a lab? Do I have a grinder? You can use it to cut the PCB. One, I don't have a grinder. I don't know why. The way you said that, it sounds like I should have a grinder. Grinder isn't that common. The second thing is the traces actually route over part of the section we would want to cut. And if not, they're really really close. So it's probably not a good idea. Um, I think I could get a micro USB connector that is thinner. So I'll probably order that right after this so that these boards are a little bit more fun to use. It is in there. But yeah, we'll figure it out. I'm going to grab a Pico 2. So back in 1 minute. Okay, I am back with Pico 2 boards. Man, there's so many little gotchas. I can't believe that one I discovered like post soldering and everything. That's crazy. Let's not fiddle with the solder. Yeah, no, I agree. I mean, I did get it. I can't unplug that micro USB cable, but it is in there. So assuming that that cable is, capable of sending data, we should be good. Okay, there's no LED on this one, so that's good. Another thing I wanted to do was just make sure that my desktop audio is coming out to you guys. Let me see. We'll know now. Yes, we will. Let me see.
The microcontroller.
Yeah, I don't know why my my desktop audio isn't getting captured. I think it's because I have this thing called a black hole. I have a black hole enabled. So, yeah, I don't know if we can watch a video together. Sorry. Anyway.
The heart of the Pico 2 is the new dual-core, dual-architecture RP2350 microcontroller. Yep, you heard it right. There are two different architectures. You have the option to choose either the ARM Cortex M33 cores or the RISC-V cores, which we will talk about later in the video. This chip takes everything that was great about
Still not showing up. So it's still not showing up here. All right, are you going to tell me how to program it? Something tells me they're not going to. No USB-C. Is that just a Pico 2 thing? I really don't want to watch this whole thing. Power consumption. Okay, that's not useful. You need a desktop manager. Yeah, probably. Yeah. Okay, how the F do you program a Pico 2? Let's go to Claude. How do you program a Pico 2? I did very little research, evidently. No, not a Raspberry Pi Pico. Is it okay, somebody said it was compatible, right? Pico, Arduino not showing up, Mac Silicon. If you're working with PCBs daily, a mini grinder is a good tool to have in your arsenal. This thing? What, handheld or the machine? I actually didn't know what you meant, but if you're talking about the handheld, I usually call that Dremel. A Dremel, which is just a random brand name in the US. Check USB connection. Ensure correct port is connected. Serial port. Arduino IDE tools, board manager, enter Pico. I don't know. Pico. Deprecated. Embed OS. What? You know, there is this. So if I remove it, do those disappear? Those always stay there, I think. Yeah, those are always there. So those cannot be the ports. To upload, oh, you have to hold the boot selection. Oh. Oh, weird. Oh, wait. Why does it say click install? Oh, wait a second. You have to install a driver? Tools, board, boards manager. Oh, I think I have to install something. Oh, okay. Sure. So this is for RP2040, but they're supposed to be compatible, which is why this thing has micro or USB B, micro B, or whatever. I guess I don't know. I was 1/10 of my attention was on that video. All right, we installed Arduino, so maybe now when we plug it in, might have to restart the IDE too. I don't know. Select board. Pico. Okay, now this is not grayed out, so that's good. Raspberry Pi Pico. I don't know. Maybe it works. I don't know. I feel like I didn't really select anything. You might need to configure permissions for uploading. Well, okay. All right. So since we're under the impression it's Pico compatible, maybe we need to look up a tutorial. Pico tutorial.
Howdy, Tinker Nerds. No, I haven't seen you in a while. Stop ghosting me like that. It's not cool. I am super excited because the Raspberry Pi Pico is how easy it is to get started with it, especially using MicroPython.
He's saying the best thing about the Pico is how easy it is to get started. That remains to be seen.
Plug it into your computer while
audio.
holding down that button. And even though I'm going to be using a Raspberry Pi computer to program my Pico, these instructions also work for Windows, Mac, and other Linux devices. So once you got it plugged in, you can release the boot select button and the computer should recognize it and open it up as a storage device. In it, you'll see a shortcut to the official Pi Pico guide on the Raspberry Pi website.
Sitting down, I need as much
how to get started with
brain energy as possible.
C or MicroPython,
none of my energy is allowed to go to my legs.
Python for microcontrollers. And if you're just getting started with microcontrollers, I highly recommend going with MicroPython because it's much easier to learn.
MicroPython. All right, so I guess I got to plug it in and hold boot select. So I'm going to do that. We hear the sound. Still no LED. It's a little disappointing. Okay, I pressed it. Is something going to show up on here? I feel like it wasn't, you know, I know I'm being a little critical, but, wait.
The easiest software for programming the Pi Pico is Thani, a simple-to-use Python editor. So just make sure you've downloaded the newest version of
Thani? It's been a while since I programmed microcontrollers.
Let's start by printing some simple text in the Python editor and then click the Run
They're using
button.
something called
It'll
Thani.
ask you where you want to save your file and you want to save it to your Pico. The Pico has 2 megabytes of storage to save your programs to. So you can name it whatever you want, but make sure it ends in the .py extension. Otherwise, the Pico is not going to
We're going to write Python, I guess?
Once it's saved, you'll see the output in the shell portion of the window.
This is
If you were
all
to hit the Run button again, you'll see the output again. Now you can start expanding your Python code and write more complex examples, and then save them and run them on your Pico. So the cool thing about this is the files are stored on the Pico itself. So if you were to take this off your computer,
I like Python, but it feels like you don't know what the hell is happening on your microcontroller if you run Python.
Isn't just to store code on it, it's being able to control other electronic devices with it. So let's do that with the most basic example we can, the blink example.
Ooh, I like that idea.
Let's create a new file, and to get started, let's import a couple of libraries. The machine library and the utime library. Libraries are basically external files of code that if we want to use them in our program, we have to import them. So with the machine library, we can create a new
Isn't it translated to C? I don't know.
Tells us
Is it?
which pin the device we want to control.
It's my problem. All right. Thani. You know, I feel like they skipped the part I really needed, which was, you know, how do I even know this thing is working?
It's a UN downloading.
It's like recognized by the system.
And then when the Pico, drag and drop onto your Pico folder once it's done downloading.
Wait a second. They're kind of implying I should have a folder, like it's mounted. Have you seen the disk? Okay, I think I know what I need to do. There it is. Yeah, look at that. I am so good at this.
Downloading. And then when the Pico detects it, it's going to reboot, and then we can start programming this sucker.
Okay, I think I missed a step here.
With MicroPython because it's much easier to learn. So to do that, we have to download the MicroPython bootloader. It's a UFC file that you can just drag and drop onto your Pico folder once it's done downloading. And then when the Pico detects it, it's going to reboot and
again.
then we can start programming this sucker. The easiest software for
I think
programming
I need
the PyPico is
download
a simple to use
a
Python
UF2
editor.
file.
So just make sure you've downloaded the
bootloader.
newest version of it, and when you start it up, in the bottom right hand corner of the window, you can select the PyPico as your device. Let's start by printing some simple text in the Python editor and then click the Run button. It'll ask you where you want to save your file, and you want to save it to your Pico.
Oh man, I feel like I'm following all the instructions for Pico and not Pico 2. You can program your Pico. Okay. Downloadable UF2. Okay, push and hold boot cell. Release boot cell once your Pico appears as a mass storage device. Drag and drop the MicroPython UF2 file. Okay. Your Pico 2 will reboot. You are now running MicroPython. Access the REPL via USB serial. Okay. We've put together a downloadable UF2 file. Where do I download it, though? Oh, download the correct... Okay, I don't think I have a Wi-Fi board because I don't see an antenna. So we'll download this. This is definitely for the Pico and not Pico 2. So hopefully it works. Drag. Oh. Drag and drop. Okay. And then it kind of implied your Pico will reboot. You are now running MicroPython. Do you think it rebooted?
Pico. But let's start by printing some simple text in the Python editor and then click the Run button. It'll ask you where you want to save.
Okay, let's do it. Print. Did I do it? Run. Did I do it? Okay, I'm pretty sure it ran it locally. Well, I was prepared for any IDE. I'm definitely going to get this all working in VS Code and like super ergonomic eventually, but I just want to use the tool. Did it just crash? What is going on? Thani. Come on. Interpreter. General. Run and debug. What is this? This is crazy. Why would they recommend this? Do you know this? VS Code, please. But look, I want to debug as little as possible. If there's a better step-by-step run a thing on a Pico, preferably a Pico 2, I am here for it. He said when he hit run,
your file and you want to save it to your Pico.
You want to save it to your Pico.
Megabytes of storage to save your programs to. So
wait, so you save the Python program to the Pico? Sorry, this is like I used to use like I don't know, like a lot of C on STM32s. This just feels like weird. Okay, but yeah. All right, sure. Main.py.
You can name it whatever you want, but make sure it ends in the .py extension. Otherwise, the Pico is not going to know how to read it. Once it's saved, you'll see the output in the shell portion of the window.
I mean,
if you were to hit the Run button again, you'll see the output again. Now you can start expanding your Python code and write more complex examples, and then save them and run them on your Pico. So the cool thing about
how do you know that's running on the Pico?
Are stored on the Pico itself. So if you were to take this off your computer and
it says local Python 3 at the bottom.
Your Python
His
code
says
and write
MicroPython.
more complex
All right, well, at least we're getting somewhere.
And then save them and
so if I
run them
click
on your
this,
Pico. So the cool thing about this is the
install.
files are
What is CircuitPython? Install MicroPython. Oh, look at that. Volumes. Oh, okay. MicroPython family RP2. That sounds right. variant. Pico 2. Oh, finally. Finally, someone has the stuff I'm using. All right, go for it. I thought I already installed it, but I guess I didn't. I've got 3 more Picos I can brick before I start bricking the keyboard ones. So. Wow. This is exciting. Python on a microcontroller. All right, local Python 3, MicroPython, Raspberry Pi Pico, and then I also have RP2040. It also says board in FS mode. Oh, I guess when I okay, let's resave it. Save it to the Raspberry Pi, main.py. All right, I'm starting to like this because it's starting to resemble the tutorial. MPY, soft reboot. Hello. All right, let's go to the blinking LED. Such a failure.
Program, we have to import them. So with the machine library, we can create a new variable that tells us which pin the device we want to control is located.
I don't know exactly
in this
what
case,
the
it's pin 25,
failure is in relation to, but I agree.
We can set the pin mode to out, meaning that we're only outputting a signal to it instead of receiving input. Next, we can create a while loop to run anything that we have inside the loop indefinitely.
I guess pin 25 is probably the onboard LED,
if I had to guess. To 1, which will send a power signal to it, turning it on. Then, with our UTime library, we can use the sleep function to pause the program for 3 seconds. And after that, we can set our LED variable to 0, turning it off, and then pause again for another 3 seconds. And then, since this is in our loop, it will continue indefinitely.
Module object has no attribute pin. Machine.oh, capital P. Soft reboot. The LED is on always. Did I forget to sleep? Device is busy. Okay, so I probably have to stop before I save. Save. Run. Okay, yeah, it's blinking. Nice. Please use this. Visual Studio. I will take a look at that. But that also says Pico W. Just an FYI in the name. Pico W is the Wi-Fi model. Might be okay. I friggin' did it. I'm like, what's his face now? That guy on Twitter who's like, oh man, I'm a hardware engineer, but then he didn't know what, like, decoupling capacitors were for. Or he asked, why do people use batteries when they can just use capacitors? Probably nobody knows what I'm talking about. Nobody's in my same Twitter rabbit hole. All right. Let's see if the other Pico shows up, because now we can program a keyboard, I think. I don't know how to make it appear as a keyboard driver with Python. I think we might be doing too much. It's for both. I'm not, but please elaborate. I don't know if I can find this guy. Let me see if I can find this guy. I swore to never pull up my Twitter on stream, but I'm going to have to break some rules. It starts with a K, his name. K-A? Just going to guess. Yeah, this guy. Yes, Yassine. Have you guys seen this guy before? He's always like, I'm doing hardcore electronics, but then he's blinking LEDs. He's like, oh, I'm building my CAD tool from scratch. But then, like, his CAD tool is, like, a cube. So why capacitor? Why decoupling capacitor? Or he wanted to know why not use capacitors instead of batteries or something like that. And the reason is capacitors discharge pretty quickly. Unless you have a super capacitor, and even then it discharges, you don't have that much time with the battery store power over a long time, yeah. Decoupling capacitors are for smoothing signals. So those are also serve a different function. I don't mean to be too dismissive. Like, there could be like a technology improvement and people work on that, but it's like, it's not like, I think I it's not even like something I would fault somebody for not knowing. It's just like, you're coming off like in his case, I feel like he came off like pretty like, oh man, dude, I'm so hardcore. He also says all the time, like, I can learn anything in 2 weeks. I mean, he's all right. I'm not a hater. but I am hating. Okay, so I guess I'm not showing what I'm doing at all right now. But I'm going to plug in the board now because, you know, why not just jump right to the board? So I'm going to hold boot cell, plug this guy in. Hopefully it shows up. If it didn't show up, that would mean probably the USB connection isn't good or the cable isn't good. And I would have to think really hard about what to do next. Okay, I'm really struggling to plug this in. Okay, I held boot select. Hopefully it appears. Test in production, that's right. Let's open up Finder here. It looks like it's showing up and there's nothing here, so it's probably the right one. So let's do the same thing we did last time. That seemed to work pretty well. Target volume, RP2350. RP2, variant, Pico 2. You know, honestly, this kind of kills. I lost that VS Code link. Somebody sent a VS Code link that I will definitely be looking at after. I'm gonna have to go through the chat. I was actually planning on looking at that, and I did not. So apologies to that guy who posted that, whose name I totally didn't forget in 5 seconds. Let's make sure this one can blink too. I'm gonna jump back over here. So stop. We need to save this again, maybe. Please use this. Okay. That's his message. AI Doom. Thank you, AI Doom. I'm just going to pull that up. Micro Pico, auto completion, remote workspace, and a REPL console. Lame. No, just kidding. This looks awesome. I love it. Yeah, I'll probably be using this. I don't want to muck around with my IDE too much, and like there's almost something fun about the crappiness of I don't even mean to diss this tool that much because honestly that install experience was pretty good. So okay, so it is blinking on the keyboard now, so we're able to program. So we good. We good. It's blinking. You probably can't see it. She blinking. Look real close. I need to get like a zoom in on OBS. Just like look real close. She blinking. Okay, so let's make a keyboard. Let's make a keyboard work. You know what I like about this is it's pretty easy to print. Here we go. Aw, shit. I've been thinking about how much I love GTA San Andreas a lot lately. It's such a good game, you know? What a classic. Okay, let's go to the keyboard design and let's take some notes on the pins just so that I know which pins are active. Okay. Something I didn't know I wanted until recently was I really wish I could hide the code. I never saw a use case to hide the code. Now I do. I really want to hide the code. It's a great feature. Okay, so pin 1 or GP0 is connect. What is this? Maybe this actually shows it a little better. So row 2 MicroPython. I think these are the yeah, so you like basically read from the columns and you power from the rows and then you flash them. If I had a schematic, it would make more sense, but I don't. So then with soldering, yes. The boards are together. They look great. They look even better in green screen. Magic Keyboard. So yeah, now we're just programming. And we can program them in Python, which is pretty cool. Although we will be using JavaScript on microcontrollers. Mark my words. We will get it done. We will be using WebAssembly on microcontrollers. like Replit agent. How is Replit agent? Like we can program it with Replit agent? Do you mean like that? That'd be fun. I'm caffeinating. We're getting the 3 p.m. sleepies, guys. And I'm so excited too. So it's hitting hard for me to. But yeah, I guess what I really want to do is get a readout whenever a button is pressed. That's like the next stage. There is JS for this, I think. Yeah, I think there's this thing called QuickJS. By the way, the guy who makes QuickJS is a genius. He's done so many incredibly awesome things for web dev. I think I got to turn off some cameras. I think I'm getting laggy. Let's see if that helps. My little computer is like, no, too many cameras. But yeah, QuickJS, super small JavaScript runner. It's like a couple kilobytes. I don't know where it is. But anyway, I'm pretty sure this works. So you just have to build bindings. QuickJS NG. What is NG? Oh, it's a fork reigniting because I guess the guy. Oh, they pull. Oh, okay. So it's like the same. Anyway, yeah, QuickJS. We'll probably use that in the future. Since AI came out, I have no fear of doing anything. I'll write assembly. I don't care anymore. It's just so easy with AI. So like, yeah, we'll do anything. Okay. So these are the pins that we have to keep in mind. So we have to flash and read from these pins. Oh, how can I do this? Maybe every second what I can do is read from these pins. And man, this is tricky. It's tricky because I have to do this without really remembering exactly how it works. I got to draw a schematic. It's impossible to do without the schematic, I think. It's just too complicated. So, I'm just going to draw a laser quick schematic to guide my thinking. Otherwise, you guys would just see me fumble around like fucking with stuff. So, yeah, okay, so there's 3 in, 3 out. Whoops. Oh, I'm bad at Excalidraw. Okay, trying to do this from memory. Because it'll... yeah. Okay. GP0, just going to label these guys. These are the rows. GP0. GP1. Vrashab's still in here. This is why we need our schematic viewer. Although this is kind of going to be a little bit more of a functional diagram. Just to help me remember how the system works. Yeah. Okay, so let's see. So you power... There's a button. So you've got an array of buttons. You powered the row, read the column. Power the row, read the column. I'm trying to like reason from first principles how this works. Sounds like it'll be really difficult, but it's really simple. So I'm just like, then we've got a diode. Yeah. Wow. Beautiful diode. Thank you. Right. Okay. So what happens is this is set to 1. This is set to 0 or low. And then I think these all get powered when you do that. My Excalidraw skills are... It's like that. So those get powered. And then I think... Each button has a diode. I'll be working on integrating the schematic viewer in snippets. That way we will be seeing bugs and incrementally better at 100%. I cannot wait. How does this work? You power this, then you get a signal here. Is that... you know what? I gotta look up a diagram. Keyboard, column, row, matrix, schematic, 3x3. No, that's not it. There we go. Multiplexing. Yeah, it's like this. I mean, I'm assuming it's wired correctly. So yeah, you read from the column. Oh, no. I had it right. Yeah, that's right. Okay, cool. So you power the row. So what they don't have labeled here is you power this row, which is connected to all of these buttons. And then you read the columns for each row. That's right. Okay. So yeah. A little bit weird. My hand drawing isn't helping things. But basically, this is how it works. And if you didn't have the diodes, the signals would mix. I forget. I'd have to reason through this a little bit more. But this is the basic thing. So what I do is I power GP0, and then I read GP345, and that gives me one part of the matrix. So yeah, okay. Let's program it. We'll find out. Hopefully I'm not debugging too much at once, because it will be very painful to debug anything without, especially with the separate lab kind of setup. We need to figure out how to read a pin. You know what? Let's go right to AI. Okay, so in MicroPython, I'm implementing a multiplexed keyboard that is 3x3. Please write a script that does the following: powers GP0 or sets GP0 high, reads GP345, sets GP0 low, sets GP1, GP2 low. I think you also have to be careful with how you set these low. I think you have to set them low, high impedance, right? Does it matter? I don't think it matters. I don't think it matters. I'll just say low. Hopefully it figures it out. That's the nice thing about AI, is it's gonna like fill in the blanks for me. So GP0, GP2 low, reads these. And then the last round is sets GP1 or GP0, GP1 low, sets GP2 high, reads GP3, GP4, GP5, prints out matrix. Fill them with proper stuff. What does that mean? Fill them with proper stuff. I hope. Ooh, oh, that's a lot of code. It's a lot of code if I have to debug this. Okay, row pins. Yeah, all right. Okay. Yeah, okay. All right. In, pull down. Yeah, okay. Yeah. Okay, great. Yeah. Matrix. Okay. I don't know. Could have done it maybe more simply. Set everything low, set the current row high, small delay to allow signals to settle. Okay. Yeah, all right. You know what? Looks good. Device is busy. All right, let's stop the device. That is annoying. Just stop it for me. If I hit save, stop it for me. I don't know. Okay, so you can see it's printing 000. If I press something, it does nothing, which is great. If I press something else, it does nothing. Okay, so there's some problem. Oh, you said AI will fill the blanks. Yeah, hopefully it's correct stuff. Okay. We are not seeing positive results here because it is always printing 0. And it is continuously printing. I can see when I scroll up. So that's pretty ASMR-y. We got some nice keyboard sound. Unfortunately, nothing is going off. So, hold. Yeah, I could hold. Yeah, it's still not doing anything. Okay. There's a couple of things here. Like, I mean, maybe the signal needs more time to settle. Maybe we're reading it wrong. There could be a lot of things going on. We could simplify it. We could definitely simplify it. So let me say, okay, everything is printing 0 all the time. Let's write a simplified script that just reads GP3, GP4, GP5, and sets, let's see, GP 0 permanently high. You know how long that script would have taken? I've never used MicroPython. Although Python is not too bad, so. Oops. Stop. Save. Play. Okay. Now it's just printing these. So GP0 is always high. I'm pressing every button. I'm seeing nothing. Let's look at this snippet for a second. Oh, it's over here. Let's just like follow the trail. So this is GP0 is the one. Also, these pin numbers could be wrong, right? I mean, I'm not really validating any of this. Pin, you know, like MicroPython pin, like to 0. Does that like what does that correspond to? Like it's not labeled 0. It's labeled 1. It's labeled 1. Oh, wait a second. MicroPython pin numbers Pico. Check Pico manual. Yeah, because they're labeled differently. I don't know if the Pico manual would have a MicroPython section. It's certainly possible. Raspberry Pi Pico 0 to 29. Wait, what? To identify the pinout diagram, the function of each pin. Pin 1. Why are there no GPIO labels on the Pico? They don't have a lot of room on the silk screen. If you get close to it, there's really not a lot of room. They actually don't label any of the pins except for pin 1 and 2. And 39. Just kind of weird. Okay, GPIO 0. You know, this is a pet peeve about electronics is they constantly use this like pin number and then they give like a word. And like clearly it's labeled a 1 up here, right? So like GP means general purpose. So it's a very specific thing. Oh, come on. Just show me. And I would think the AI would get that right, but Oh, can you give it a string? I'm just going to give it a string. Life-changing hack on the Mac is I map the right command to to like, I don't know, mess up my keyboard so that it uses Vim key bindings, and now I have Vim key bindings everywhere, and I love it. Why not print all the pins? Yeah, I mean, not a bad idea. We got time, you know? Okay, still nothing. Still getting all zeros. But the fact that this compiled at all is good news, because I feel like I have a little bit more certainty now. Granted, like, I wonder if I put hoopla in here, like, okay, no, unknown pin. So that is to be trusted, probably. GP0. So let's just walk through the path of the electricity here. So we have GP0. Man, I really wish I could make this bigger. Wah. Okay, so this is what we're powering, pin GP0, and it is. Oh, wait a second. Oh, well, this could be it. This line on the diode indicates that it's negative. So this is set up backwards. So I think I need to power the other pin. Yeah, I think I need to power the other pin. So let's see. GP345. Oh god. That's GP3. Okay, cool. So GP3 powers these guys. Okay, no big deal, but I had it set up backwards. So GP0 is actually an input. Okay, I made a mistake. You got to come clean with Claude. GP3, GP4, and GP5 are the outputs, and GP0, GP1, and GP2 are the inputs. Also, can we use strings like pin GP3 pin out? Oh man, Claude, get that mobile experience going. GP3 pin dot out instead of numbers. Thank you. Okay, now it's rewriting the whole program. It's giving me the long version. Oh, actually. Oh, this is nice. This is actually a nice little script. Okay. Cool. Let's do it. Save. Run. Okay, now 2 of them are high. Nothing changes when I press things. GP0, pin in. Okay, that looks good. GP3, 4, 5, pin out. We're saying GP3 high. Oops. What about reading the input for the first key to simplify things? Reading the input for the first key. I mean, I'm reading all the inputs right now. I figured that would be easier to just have all the inputs, because I'm trying to avoid actually like doing the debugging thing of like breaking it down into its simplest thing where you look at exactly one key in isolation, because that would require that I know how things are connected a little bit more deeply. I will as this problem goes on, I will definitely do it, but I feel like we made a little progress already by realizing everything is backwards. So GP0 is an input. Just doing some quick check. Okay, yeah. Wait, GP2. This is GP2. Okay. You know what's interesting? Pull down. I don't think that's right. Open drain. What do? I don't think that's right. I'm trying to think. It's open drain maybe? I forget what these mean, but basically a pull down means it's going to be pulling it down. Maybe that's if it's an input with a pull down. If it's an input with a pull down, it would need to be pulled up. Is it being pulled up? Maybe it is. I feel like there's one that's like high impedance. It might be, I don't think it's open drain. Pull hold. Oh man, it's been too long. Where's my Claude? What happens to voltage when pressed? Where? You know, what happens to the voltage where? That's the question. When you connect the button, these pins are supposed to be pulled high. Yeah. The GPIO pins. Yeah, the input GPIO pins are supposed to be pulled high when you press the button. But it's a little bit difficult for me to think about because there's a diode there. What I really want is just a high impedance. Can we set the input pins to a high impedance input? You just don't do anything? To use high impedance, no inputs. I don't know. So it's kind of interesting. The fact that GP 1 and 2 were high means they were being pulled up for some reason. Yeah, I don't know. I need a schematic. Okay, now they're all high. And when I press things, nothing continues to happen. Oh, I think I gotta break it down. I also do have a multimeter here, so I could see if the Raspberry Pi is basically not getting it. You know, like maybe there's a bad contact with the pad or something. But yeah. GP, let's see, output pins value 0. Drive. What is value? Get and set value of the pin. Is that right? I've never used MicroPython, so like we're learning. Docs. General board control. Pins in GPIO, P0.on, set pin to on or high. Okay. Set pin to on/high. Okay. I think these do the same thing. Create an input pin. Enable internal pull-up. Set pin high on creation. Let's try. I'm just running some experiments here. Yeah, no change with GP4 being the one that's high either. Just in case like one of these wasn't making contact. Okay. Pin dot value. Pin dot in by default is floating, high impedance. Nice. Yeah, why don't they have did it say floating earlier? Did I miss it? Is that an option? Floating? Like I feel like I'd love to explicitly set it. Another interesting experiment. If we set them all to low, we're still reading high on every input pin. Even though I don't know. We were getting low when we set them to was it pull down? No, we're still getting ones. Very interesting. I'm going to double check on the multimeter. Actually don't know what the pico, what ground is, so I got to find a quick diagram that just tells me what ground is. I think top right might be ground. V-bus, nope. What's that? V-sys, ground. Okay, so kind of 3 down from the top right. Okay, so according to that, pin 1 is low. So now let's make pin 1 high. We're just going to test some basic assumptions here. Pin 1, oh, that's actually an input pin, but it's being pulled down. So theoretically, if I do pull, oh, what the heck? Now it's reading 0 here. Wasn't it just like 1 all the time just now? And I was like, why is it always 1? What, did I press it into place? Maybe my soldering job was terrible. Shield of USB cover is ground. Shield of USB cover. Is that true? Really? They connect that to ground? It's not always true for enclosures. That is good to know, though. Okay. Really quick. Man, I could have swore that was not just... Whatever. I'm just messing around. Trying to build my mental model of this really, really quickly. Okay. That's not changing even when I have GP3 high. Okay. All right. There's so many little things we can test. Yeah. Okay. So roughly my process is to verify each thing that I'm programming because I've never used this before. So like pull up, right? So GP0 should now be high. There's nothing pulling it down, so it should be high. So it's high here. It says it's high here. So then if I go over here, okay, it's saying it's negative 3.27. That's not right. Negative 3.27. That feels like this is not ground. Oh boy. Pico 2 pinout. $38. Oh, I maybe was connected to power. Negative 3.27. Are my probes in wrong? Oh, yeah, my probes are in backwards. Wait, are they? Yeah. I think my probes are in backwards. Okay. Okay, 3.3. So that's something I just remembered, is that this board is 3.3 volts. That probably won't cause anything I did previously to be broken. Okay. So the pull up definitely works. We could check that these outputs are coming out proper. Yeah, and I think what we can do is just starting with GP3, we can follow the path. I can connect to each diode and we can just see where it all goes wrong. There's a good chance that it's not able to. I think it should be able to pull these pins up. I think it should be able to pull up the pins. So, especially when it's in high impedance. Yeah, there's like something I'm a little concerned about, which is, yeah, no, I think it should work. I think it should work. All right. So we're going to set this guy to high, and then we're going to follow that path. These are all 1. They're all being pulled high for some reason. Why would they be pulled high? I'm going to feel so dumb after I figure out what's going on here. Okay. Let's move the code over here. And then... So the path I want to follow is GP3, which is the 5th one down. So first, this guy should be high, right? We set it to 1, so this guy should be high. So let's confirm that. I might need a new camera. Yeah, I think I need to bring in a different camera because I don't want to keep switching views. Let's see. Video capture device. Not that. Maybe this. Yeah, okay. Set this down here. All right. A little bit less work for me. Okay, GP3. This guy. Actually, you know, maybe we can make this camera a little better too. A little bit more fun. Actually, let's do this. Turn this guy off. You know what? Good enough. Good enough for comedy. Okay. I hate how I have to zoom in on that to see the name. Anyway, that's GP3. It's 5 down. Okay, well, first thing learned, that is not... I'm getting 0 on that. Yeah, I'm getting 0 on that. So it seems like that output is not going high. Wow, that camera is very flaky. What methods do we have on an output pin? Wow, this autocomplete. Set pin high drive, whatever, Pico. Drive specifies the power output. How value equals 1. We could also try initializing them a little bit differently. So maybe I comment out this code. Value equals 1. Value equals 0. I mean, if it's able to drive an LED, it should be fine. Okay. Okay, now it's being driven high. Other weird thing, GP2 is 0 for some reason. I think I'm pretty confused by these input pins being high. I do not understand that. Yeah, what would be driving GP0 and GP1 high? Are they even high? Is it real? Yeah, it doesn't read as high either. None of those read as high. Oh, and they're not. What the heck is going on? Oh my gosh, every time I touch it, it seems to change. I'm bewildered. Maybe it's possible that there's a really bad contact. Like that when I push down the PCB, I'm like reestablishing contact. You're not the first one to attach keys. I'm sure someone shared. Oh, you mean their code? I don't think it's the code. I don't know. I'm skeptical of the solder job. That's what I think. Why would that change? Or like an old version of the code is being uploaded. Yeah, because it's like I touched it and it changed here. All right, so this pin is high. We're going to validate that. Just taking it step by step, you know? until we have a good mental model of all of this. That's how I learn. Okay, so that's high. That's good. GP0, low. Key presses. Not changing anything. Oh, there it goes. It just went high when I touched it. Like, I kind of feel like maybe the solder job is kind of bad. If I just push down on this pretty hard, and then I press these, does it do anything? I was able to make GP0 go high. Or GP1. I don't know. I don't know. Okay, let's try touching these keys. And checking with the multimeter. It's ground, right? Yeah. I knew I wanted to put LEDs all over this board to validate, to make it easier to debug this, but I didn't, and I regret it. Trying the other Pico, I might do that. I don't mean to be like too slow, but like I'm just it takes a little bit to build the mental model. Trying to think if yeah, it's GP2, okay. If I set all the buttons to high, if I set all the outputs to high, that means every button has power going to it on one side. I think that's probably the easiest state to debug from. At least now that we're consistently getting zeros. Okay, so we have all zeros here. Push a button, nothing. It's almost like, I wonder if, like this, oh, so now it's 1, but it's being held at 1. Let's stop this for a second. Yeah, it went to 1. It went to 1 at different times, too. It's strange that this doesn't go back down to 0 there. I think it's not supposed to be a pull down, so I'll put that, make that more in its correct state. Yeah, it's weird that these continue to be high. Like, it's like, it feels like the microcontroller isn't being reset. Like the pin states are somehow not reset or something. I feel crazy. What is open drain? I forget what open drain is, but it might be the mode I want. What is open drain on a pin? Means the output pin can pull the signal to ground, logic low, but cannot actively drive it high. I don't think that's what we want. In MicroPython, how do you set a pin to high impedance input? It says it does by default. Maybe the unstable reading here means it actually does need a pull down. That might actually make sense because it's not being pulled down. It is literally floating. Yeah, so maybe it needs a pull down. It's so weird that it's like persisting that one. I'm gonna like unpower and repower it. I don't know. I'm spooked. I wonder if it won't work now because I think I didn't put it in boot select or whatever. I just don't know a lot about picos. Let's see. No, it seems to run. And now they're all 0. So am I able to trigger it again to get to 1s? I'm being more careful. Okay, I just triggered it to be for somehow permanently 1 when I hit this button. So we can see if that's consistent. This one triggered it to be permanently 1. Okay. So we've got 2 buttons that trigger it. I'm going to see if that's consistent. So now they're... Okay. Gave it another power restart. Okay, so now we're 0s again. Okay, that is very consistent that these 2 buttons trigger it. And then afterwards, they stay high. I almost want to explain this entire situation to Claude. See what it says. So these are the 2 buttons. These bottom right 2. So we should be setting this one to high. And then when we connect the button, let me double check these diodes. Are they placed correctly? Yeah, I think the diodes are placed correctly. Could check the diode direction. Hello. Okay. I'm going to check the diode direction without this board being powered. Oops, wrong mode. Yeah, so confirm that this is negative side. Hi. The weirdest thing is it's like the row column being powered backwards thing. So hmm. Okay, I have a theory. I think I just figured it out though. Yeah. I think the issue is I need to make these guys pull ups and this be an output pin that pulls it down. So I think I was just confused. So basically these guys all need to have pull ups.
Okay. Well,
Python. You love Python.
Python. Are you still muted?
I turned my mic on.
Oh, okay.
Nobody can hear you because I have background suppression on.
Okay, so you're saying I'm background noise?
Your background noise. Well, actually, I'm not saying your background noise. OBS is.
How do you know I'm not heard?
It shows up in the mic if you're heard.
Really?
Yeah.
Oh, look at that.
Yeah.
Yeah, I'm not heard at all.
You're not coming through at all.
Wow.
Yeah. It's the high pitched kind of. Well, I guess.
What if I talk like this?
Yeah, it shows up a little better. What about keeping all the input GPIOs just floating and read their state on button press? I think I tried that. Nah, you can't hear. I can hear, bro. I think I was confused. I think I have everything backwards. I know. It's all in my head. If I had a schematic, I would show you guys the schematic. I would draw over it. But this is gonna work first try. Don't even worry about it. Wait, no, input. I can hear. Me too. You guys can't hear. You can't hear. Yep, I really want to see the schematic. Yeah, it's kind of impossible without the schematic. Not gonna lie. Look, I don't like to operate like this, and we almost have the schematic rendering, but like I'm way too lazy to draw out that whole schematic. It'd be like a whole. This is supposed to be the prototyping stream, not the design stream. Okay. Yeah. So these are pull-ups. These are. We have not tried this configuration, so. Yeah. So these are value high, and then when you want to test it, you set it to 0. When you want to test a row, okay. Yeah, this is gonna work. Don't guys just like trust me. Trust me. I was wrong before, but I've seen the light. This is it. I just had to think hard enough in my head, and I've seen the light. I've seen the light. This is it. Stop. Save. Run. All right. I don't know why that one is 0. Don't ask me to math that. So, oh man, is it not doing anything? That's so embarrassing. I was pretty sure I had this. Okay. This is an, so we're saying this is an input that's pulled high, and then, yeah. Okay. So this is an input that's pulled high, and then when you press a button, it's going to be pulled down. That makes way more sense. Yeah. That makes way more sense. Because this is connected on basically these diodes. Oh, it's only bottom row that affects us. Okay, that's a good that's a good learning. I was pressing buttons I shouldn't have been. It's really hard to see with these highlights, and also hard to see when my head's in the way. But you can see when I highlight this pin, the bottoms of these diodes are highlighted. So basically what's going on is these diodes have the ability to pull it down, but they're only pulled down if this button connects to a ground from one of these buttons. So that's what's going on. So if we set them all high, I'm gonna have to draw the schematic on this. If I can't get it soon, I'm gonna draw a schematic and actually do math. But that's good. So they're all high right now, so GP0 is high. What doesn't make sense is if this is low, it's gotta be a faulty connection. Yeah, that shouldn't be low. The only thing, GP0 is pulled up, so something is pulling it down. I have no idea what's pulling it down. So that's wrong. But let's skip GP0. Let's go to GP. Let's go to GP4. Okay. Wait. Oh man, what is going on? Oh, these are mislabeled. All right. Getting lazy. Look, look, my brain works the least well at this time of day. Everything was labeled wrong. Forget everything I said except for the high-level explanations. We were reading the output pins. Okay, here we go. Okay, so these are all high. Nothing I do will matter. That makes sense. We pull one of these low. This is going to work. I'm so confident. All right, so now I push that. Nothing. I push this. Nothing. I push this. Also nothing. What is going on? Hold on. Oh my gosh. Oh, I don't want to have to do a schematic. I'm going to have to do it. GP3 is this one, right? Okay, GP3 is this one. So if you press a button on the microcontroller closest side, it should... It was nice meeting you. Keep up the good work. Thanks, AI Doom. Good seeing ya. There will be a conclusion to this at some point. Thanks for stopping in. This is pulled low. This diode might be backwards. Is that right? I'm going to annotate this. Okay, so this is the top left key. And this guy is connected to GP3. Okay. And this guy is connected to this diode. So this is connected to... Wait, what? This guy is connected to GP2. Okay. Right. Oh my gosh, Excala draw, you crazy cat. Okay, this guy's connected to GP2. Oof. GP3, driven 0. GP2 pulled high input. So if we do a mini schematic for just this section, we have GP3 driven 0. You have your button. To the diode. We have a pull up. I think it's 3.3 volts for some reason. I don't know. I see both 3.3 and 5 volts on this board. Right. And then that goes to GP2. So yeah, the diode, it seems to me like the diode is backwards. If it's going to be, if you're driving this to 0, you want this diode to be flipped so that it can be driven low. You want to take this high voltage and drive it low. So I think there's actually a design issue. Should be driven low. Yeah. At least with this configuration. Yeah, it looks like I reversed the diode. That would have been more recognizable if we had schematics, but yeah, not much I can do now. Oh, it's a shame I used 2 Pico 2s on this. I could probably get them off, but is there any mitigation? So this is essentially the, or whoops, should be flipped. So basically, if you have a circuit like this, I'm just removing the arrows because it could go either way. Is there any way to like turn this functional? And I would guess probably not, but we can explore it for a second. See if this is salvageable. Stuff is starting to make sense though. Why like we are seeing sticky behavior. So for example, if we drive this high, there was, so what I was trying to do at least, oops, when I finally did the schematic, what I was trying to do at least was definitely the diode was the wrong way. So like GB2 pulled high, so you have 3.3 volts here, and then I was trying to drive it low. So definitely this diode needs to be reversed for that pattern to work. So I'm trying to see if there's any way to salvage it. So for example, if we pulled high here and then we drove this low, I think that would work. And then this would be pulled. See, it's a little weird because it's not going to be pulled to 0. It would be pulled to I'm not really sure what it would be pulled to. I think it would depend on this resistance. So you're going to have a it's sort of 7-inch or 7-inch. Let's say 6-volt voltage drop across this. So kind of depending on the impedance of this full circuit, you'll have some voltage here that's like 0.6 volts or something. If there's zero impedance across the rest of the circuit, you would have 0.6 volt here, which should be enough to drive it low. But I definitely think I did not mean to reverse that diode, so that's unfortunate. But let's try this from scratch. So I'm just going to name these their actual names. So GP3 equals pin GP3 pin dot. We want this to be an input with pin dot pull up, and then GB2 is going to be an output with a value of 0. So when the button is pressed, I should clarify this. Pressed, we should be 0.6. Not pressed, or we can say open, 3.3. Right here at this point. Yeah. I really could use Copilot. GP3 dot format, GP3 dot value, maybe. Okay, so right now it's 1, which is correct. And if I press the top left key, it should go to 0, but it doesn't. GP2 driven low. What is that? This is why I don't like using Python too, because I kind of want like the exact parameters that the Pico people like would have given this guy. So like I don't know what this drive parameter is necessarily. They don't mention using drive at all, but there's a drive parameter to pin. Yeah, drive strength. 4 milliamps. It's not very much. I'm kind of curious about this open drain setting too. I'm just going to mess around with this for a second. Oof. Oh, I think we need to sleep in this loop too. We did not sleep at all. So time.sleep. I don't know. 0.1. Can I do that? Okay, cool. Yeah, that didn't change anything. Oh, wow. Oh, there's way different amounts of currents depending on how you configure it. But it looks like they had to manually change the memory. Oh, huh. Wow. Fried pin. Pico will not power all of... Hmm. Yeah, maybe a difference in 2350. I wonder what would happen if I configured this guy as a pull down, which should have a similar... Actually, I don't know. Yeah, it's not going to do anything. Okay, I'm going to do some multi-meeting. So first thing is GP3, which is 5th down. I want to see if it's actually pulling low. Oh, it's not. It's pulling high. Just comparing it to this guy. That's ground. GP3. Are my pinouts wrong? GP3, 5 down. Yeah, 3.3. GP3. Wait a second. Wait. GP2 is actually the one I was looking for. Okay. I think they're right above each other. Yeah, that is being pulled down. Then when I press the button, no change. Okay, no change across the button when it's not pressed. Or pressed. Actually, it might be reading slightly, very, very slightly high, like 50 millivolts when it's not pressed. Then when it's pressed, it reads 0. I think there's enough impedance along this path. What is the impedance of the pull-up? Impedance of pull up resistors, RP2350. Latching of the input pulling resistors. Pull down latching. We're not using pull downs right now, though. Oh, the errata export. So these are problems with the board. Okay, so I don't know if that affects us because we're not using pull downs. We're only using a pull up. This is kind of... I'm going to do some more measurements. I think... I think I need more crazy debugging diagrams. I feel like I can get this to work. Like there is a hardware bug, but I still feel like you can reconfigure this such that it works. But something that is constantly confusing me is I need some like consistent, like it sucks to have to keep zooming in on this. So this guy is GP3, this guy is GP2, and this guy is ground. Those are our main pads for comparing stuff. Oops. Oh. Okay. Yeah, 1, 2, 3, 4, 5 is GP3. 1, 2, 3, 4, 5. Okay. So GP3 is definitely high, but what's weird is one side of the button isn't high. I'm trying to figure out why that could be. And it might be that there's a lot of impedance in this section right here. If there is, like you know, you might get a lower voltage, but one side of the button should really be high. I almost want to take off the switch. It'd almost be easier to probe. Yeah, I'm getting 0 on both of these. It's so weird. So basically you start here. You go to here, so the nearest one should be high. Like if it's 3 volts here, maybe I messed up the via. Because I did have a via in pad. So I mean maybe that via got cut off. Still getting 0 on this guy. These are directly connected. It's basically a wire right between these. Like the only way that would be happening is if the via got messed up. We could try taking a look at this one. There's a different via. See if this other button's high. It's not high either. All right. I think there's a third out of here, maybe. There should be. But I think it's not being routed right now. But anyway, this one should also be high. Not high. I am not sure, but I don't want to be debugging this too long on stream, mostly because I'll have to edit this later and try to figure out when I had my epiphany. So I think I'll pause it for there. Yeah, I don't know exactly what's going on, but I will figure this out. This should be salvageable. So, yeah, I'm just not sure why we're not seeing. We're basically measuring between here and here, and we're not seeing any voltage difference. And I can't figure out why. I don't know why that would happen. So yeah, I'm not sure, but that's not really like in the code, right? It's pretty straightforward. If it's high over here, I mean, unless there's some behavior with the pull-ups where they're just like ultra high impedance pull-ups, which is possible. But otherwise that should work. So I don't know. I guess I'm gonna really dig in and try to figure out why we're not seeing it between these 2 points, and then I'll continue onward and we'll hopefully get something working. But like nothing inherently wrong with this circuit. It's not great that this is an internal resistor and not an external resistor. But I don't know. We'll find out. I saw somewhere that it's 60 ohms, the resistance here. So, or sorry, 60,000 ohms, which is a lot. It's really high. So it's possible that there's enough impedance between here and here. There's essentially another resistor between these that you wouldn't see it, but with the switch high, with the switch open, you should still see something. So it's just pretty weird. I'm gonna take a look. Maybe we messed up the via. Could be a lot of things going on. So I'll keep debugging that. Should be fun. but probably not fun enough to do on stream. So thanks for joining if you joined, and can't wait to see what happened here